questions from homeworks. So at this point, we've assigned worksheets 1 and 2, as well as like 11 to something and something and something from yesterday. What were they? 11 to 14 and then 17 to 18. And what else do we have happening this week that we should also be aware of? Homework quiz. What is that homework quiz covering? Yeah, really worksheets 1 and 2. So any and all of that kind of stuff is fair game for questions right now. Give me a flash me hand and we'll hit your question. Oh my God, Mariana. Number 3, you said, from worksheet 2? Sure. So if I'm leaving out a detail or whatever, just interrupt me, okay? I will do my best to be as thorough as I can, but if you're like, feel like I'm missing something or you're missing something, please feel free to interrupt. Because I do want to make sure I'm giving you what you need. Okay, so when I look at this problem initially, the first thing I'm going to do is look at the number that's inside of my inverse function to see if this is a unit circle problem or a calculator problem. When I see negative 5.25, as soon as I see a decimal that isn't 0.5, 0, or 1, I know it's going to be a calculator problem. Everybody cool? Okay, so to start a calculator problem, I'm going to draw a picture. So I'm going to start with just like an XY axis. And the first thing I'm going to do is figure out what 2 quadrants my answer needs to lie in. Because I'm told that my answer needs to be between half a pi and 3/2 of pi. So I know since that is going to be a positive number, something between 3/2 pi and negative 3/2 pi, when I draw my standard position angle, I'm going to be going counterclockwise. So we always start at the positive x-axis with 0, and then we're going to be counting in the counterclockwise direction, so like that way. And I'm just going to be counting by 90-degree increments, since each quadrant is 90 degrees. In radians, I know that 90 degrees is pi over 2. So I'm just counting by like half a pi. So the first quadrant is half a pi. The second quadrant is another half. So 1/2 and 1/2 is 1. And then will be 3/2. And that's where I'm going to stop labeling now, because I've gotten to the end of that increment. So if I look at the stuff where I started at pi and I ended at 3 pi over 2, I'm looking at quadrants 1 and 2. I'm at 2 and 3. So far, so good? Okay. The next thing I'm going to do is I'm going to look at my inverse function. So if if theta equals tan inverse of negative 5.25, that tells me that tangent theta is equal to negative 5.25. Or really what I care about is that tangent theta is negative. So if I go back to like my all silly turtles crawl, that tells me what trig function is positive in each quadrant. So A, all of the trig functions are positive. S, sine is positive. So if sine is positive, the other 2 are negative. T, tangent is positive. I don't want that because my tangent is negative. And then C, cosine is positive. So the other 2, sine and tangent, are negative. So far, so good. What this tells me then is the terminal side of my standard position angle needs to lie somewhere here in quadrant 2. Because that's the place where I'm in between pi over 2 and 3 pi over 2, and also tangent is negative. So this is be what my solution looks like visually. So far, so good. I'm now going to draw in my angle alpha. My angle alpha is always made between the terminal side of theta and the x-axis. So that would be my alpha. And I always calculate alpha by just doing the inverse trig function of the absolute value of whatever the number was. Still good? Okay. So now I'm going to write my equation for theta. Bless you. So to write my equation for theta, it's always going to be the piece of the x-axis that makes up my angle alpha. So in this case, that is pi, because you see how that part of theta, or part of alpha, is pi. Is that okay? And then it's always going to be either plus or minus alpha. I can tell the plus or minus piece by whether my theta is positive or negative, and then which is the most, or the which axis was the last axis I crossed before hitting that terminal side. So in this case, it was the y-axis. Did you see that? Actually, let me use a different color. So that's going to tell me it's minus. So the rules here is theta is negative, and we have the y-axis. That implies subtraction if theta is negative, and we cross the x-axis last. That would be adding. Oops, I meant we were doing positives first. Sorry. And then if theta is negative, it's just the reverse rule. So that's like my rule for deciding whether that's a positive or a negative. Okay. The only reason I'm drawing this picture is so that I can write this equation. That's the purpose of drawing the picture, so I know what number do I need to add or subtract alpha from. So all I'm using the picture for. I draw the picture the same kind of way every single time, and I formulate my equation using the same rules every single time. Now that I have that equation, I'm going to go to my calculator. And I'm going to do pi minus tan inverse. And then rather than doing the absolute value in my calculator, I'm just going to do that in my head. Because, well, to make something positive doesn't require too much brain power, and it's like way faster than jumping through all the menus to get the absolute value out of that. So I press enter and I get 1.75. So that is my answer. But every one of these answers is checkable, and I'd encourage you, especially as you're going through and working on your homeworks the first time, to do the checking. So the way we're going to check this is the check is two parts. The first thing I want to check is to make sure if I do tangent of this angle theta, I get that negative 5.25 back. So I'll do tangent, and then I can just like scroll up and grab my answer, or I can press second and the negative sign to get the ans command, which is just calculator shorthand for the last answer that it output to you. So if I do that, I get negative 5.25. That's good. The second half of my check is to make sure 1.75 is bigger than pi over 2. So I'll just type in pi over 2. 1.75 is bigger than that. And it has to be smaller than 3 pi over 2. So again, I'll just type that into my calculator. But I see that, yes, 1.75 is smaller than that also. So I know I've landed at the correct answer. Mariana, how did that treat you? Was that thorough? Okay. You guys want to do another like this?
Yeah.
Great. Do you have a preference on which one? Anybody with a preference? Should we? Well, let's do one where we have a negative answer, eh? So I'm going to just jump to 7.
You just plug in the first part.
So once I have this equation, I just type that into my calculator. So the picture is just so that I can get to this equation that just goes right into my calculator.
Second part, right?
Which is, yeah. All right, so let's do 7. All right. The first thing I look at is make sure to check to see if this is a calculator problem or a unit circle problem. What do I look at to decide? Just looking at this number, right? Is that a unit circle number? No way, Jose's. So we know we're going to be using the calculator. So the next thing I'm going to do then is going to draw a picture and figure out what 2 quadrants contain those angles between those 2 measures. Everybody's okay? What do I notice about my angle theta here? If it's between 2 negative numbers, it has to be negative. So when I start my counting, which way am I going to be counting? Clockwise. So again, I always start at the positive x-axis, but this time I'll be counting in this direction. Everybody's okay with y? How much am I counting by? Each quadrant is a half a pi, but since we're going in the clockwise direction, we're really counting by negative halves, right? So I have negative half a pi, negative 2 halves, or just negative 1, and then negative 3 halves. So going from negative half to positive half, I covered quadrants 2 and 3 once again. So far, so good. Now I'm going to look at my equation here. If theta equals sine inverse of negative 0.2 or negative 0.56, that's equivalent to saying sine theta equals negative 0.56. So really the thing I care about the most is that that number is negative. Edie, this is for you. So far, so good. Stop me if I lose you. Okay, anybody? Then we do all silly turtles crawl. Remember, what these letters are telling me is which functions are positive in that quadrant. So in quadrant 1 is A. That tells me that all of my functions are positive. We care about where sine is negative, so we don't want quadrant A. Quadrant 2 is S. That tells me sine is positive there. We don't care about that. We want where sine is negative. In quadrants 3 is T. Tells me tangent is positive, but the others must be negative. And then quadrant 4 is C, telling me cosine is positive, but the others must be negative. So sine must be negative in quadrants 3 and 4. So far, so good. I'm now going to draw my standard position angle. So the initial side always on the positive x-axis. The terminal side will be in quadrant 3, where the two colors are overlapping. And because theta is negative, I know I'm going to be drawing that angle clockwise. So far, so good.
How do you know which way you go? If you're going clockwise.
If theta is between two negative numbers, means theta is negative. Negative answers go clockwise. Positive answers go counterclockwise. So I'll draw in my alpha. My alpha is always drawn between the x-axis and the terminal side of theta. So there's my my alpha right there. Everybody good with how I drew that in? Thing you have to remember is always between the x-axis and the terminal side, never the y. If I write my equation for alpha, well, I know that's just going to be my inverse function of the absolute value and now I'm going to write my equation for theta. So I start with the label on the x-axis that makes up one arm of alpha. In this picture, that number is negative pi, right? Alpha is here, so that's the number I want. Everybody okay with how I did that? And then I'm going to be looking at what's the last axis I crossed before running into the terminal side. That's a y-axis. So if I go up here, I have theta and is negative, and we crossed the y last, so we should be adding. That's my little rule. And now it's just calculator time. So negative pi plus sine inverse, and I'll do the absolute value in my head. So I get negative 2.55 abouts. Now to check that, I'm just going to do sine of negative 2.55 and see if I get negative 0.56 back. I do. And then I'm going to make sure that negative 2.55 is in between negative 3 pi over 2 and negative 1 pi over 2. Well, it's bigger than negative 4.7, and it is smaller than negative 1.57. So I am for sure convinced that I have the correct answer because it satisfies the equation and it falls within the specified range of values. What do you guys think? One more time. Mariana?
But if the number in the parentheses, like if there'd be negative 0.56, if it was positive 0.56, would you
Correct. Yes, correct. So the blue stuff would have been in quadrants 1 and 2 instead of 3 and 4. That's correct. What do you guys think? One more of these? Sure? I mean, I know how to do it. I'm just asking what you guys want to do. Let's do 5. I think 5 is the most annoying one, just because of the counting piece of it. All right. Is this a calculator problem or a unit circle problem? Calculator, how could you tell? 0.19, right? It's a decimal. Everybody's cool? All right, so we'll start by drawing our picture. And I'll start by labeling my axes. When I do my labeling, should I be going clockwise or counterclockwise? Counterclockwise, good. Why? Right. I know theta's in between two positive numbers, so it has to be positive. Okay, so we start at the positive x-axis with 0. And then how much do we count by? Half a pi. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Well, because I have to get to 11 to 12,
Okay.
right? So I just am going to keep going around until I get there. So that was at 8 halves. Now we're at 9 halves. And we're at 10 halves. And then 11 halves. And then 12 halves. And then 13 halves. And then 14 halves. And then 15 halves. And then 16 halves. And then 17 halves. And then 18 halves. And 19 halves. Then 20 halves. 21 halves. 20 halves. Aha, that's or 22 halves. That's the start. And then we're at 21 halves. Oh, I'm sorry, 23 halves. And then 24 halves. Woo! That was super annoying, Mr. Kulik. I know. So we're looking at from 11 to 12. That would have been quadrants 3 and 4. This was the only one that was like super annoying. Yeah, Troy. You'll get the wrong answer. Okay, so it says between 11 and 12, right? So 11 starts here, and we're going counterclockwise, and 12 ends here, so it should be 3 and 4. Does that feel okay?
Yeah.
So you got to remember the direction that we're turning, right? In this problem, where everything is going in that direction. Sound good? All right. So we know that the starting problem is equivalent to saying cosine theta is equal to 0.19, or really what we care about is just that it's a positive. So all silly turtles crawl. What two quadrants are cosine, or is cosine positive in? 1 and 4, A and C, right? A for all, C for cosine. Remember, the letters are always telling us where things are positive. So where is my terminal side got to be at? in quadrant 4. So initial side, terminal side. So to get there, really we're going around 1 time, 2 times, 3 times, 4 times, 5 times, and then running into our answer, or running into our terminal side. Is it necessary you draw the entire spiral there? Not really. What do I need from that picture, though? Or what do I need from that spiral? I basically just need to know that, right? Where's the last axis I cross before hitting that terminal side? Okay, let's draw in our alpha here. Oops. So alpha is going to be there between the x-axis and the terminal side. So again, we'll take the absolute value. Here it doesn't really matter though, because the number was positive anyway. So like the absolute value doesn't really do anything, but I'm always going to write it because the time where I forget to write is going to be the time that I needed to put it there, and then I'm going to get it wrong because that's just my luck, you know? All right, so let's write our equation for theta. So what number is first here when I write my equation for theta? What do I write here? Not 4 pi, 12 pi, right? Notice that when I drew that, I was careful to cross out the old label and put the new one in. We're always looking at the most recent label. So far, so good. And then the other piece I care about is right here. Since theta was positive, and we crossed the y-axis last, I'm going to be subtracting. So my answer should be 12 pi minus alpha. Or 36.32. To check that, we'll do cosine of that and make sure I get 0.19. I do. And then I want to make sure that's between 11 pi and 12 pi. Well, it's bigger than 11 pi. That's good. And it's less than 12 pi. That's good. So I am 100% convinced I have myself the correct answer. You guys feel any better about doing this process? Notice again, all these problems, if I just follow the algorithm as we described, they're all exactly the same. It doesn't matter like how many times you're counting around, you just keep counting. Doesn't matter which spot it ends at. You just follow the rule on how to write your equation. If you use the rules that I've laid out to you, every problem is can be done exactly the same. There's no like different method that we need to do. It can all be exactly the same, which is what I'm shooting for when I design like how I'm going to teach this for you guys. Because I'd rather have it be a little bit tricky, but always the same, than like, oh, you have to really look at what's going on and select like these 4 different things that you could do. It's like, I don't want to do that. Let's just have like one way to do it, and that's it. And I like drawing the picture. Like to me, it reinforces a lot of previous learning. Like writing a standard position angle, what quadrants are things positive and negative in, like using vocab like terminal side, initial side. Like these are all things we've talked about before. So I think this is helpful in at least like going back and tying in some of these previous ideas back together. And then it's visual, and I'm a visual guy. I like being able to look at something and go, okay, I'm going to turn this equation now, or this picture into an equation by looking by what it looks like. I like that. It's satisfying to me, like I'm doing something. Okay. Any other questions on homework before I start the new stuff? Okie dokes. Here's the good news for you guys. The new stuffs today is pretty easy. It's really just two ideas. So the two pieces of new vocab we're going to see in this section is an angle of elevation and an angle of depression. I'm not going to define what these things mean in words because a verbal definition is going to help us any. What I'm going to do is define these two things visually. So imagine you have like one person up high and then one person like down low. So let's say that they're both at the first or at the beginning, looking straight ahead. So that's like their line of sight. The person up high has to turn their neck down to see the person low, right? This is an angle of depression because you're going from high and then turning your neck to look low. If you're the person on the bottom, you're looking straight ahead. To see the person up high, you have to tilt your neck up. So that's going to make this an angle of elevation. Everybody's okay there? This is the gist of it. What can we say about the angle of depression, the angle of elevation? Geometry, people. They are alternate interior angles. They would be congruent. What can I say about the angle of depression and this angle here that I've starred? They would be complementary. They add to give you 90 degrees. Remember that those two angles would be consecutive interior angles. The sum of consecutive interior angles is 90 degrees. These are things that ideally we remember from geometry. I think we typically do a pretty thorough job on, like parallel lines cut by a transversal, spend a lot of time there living with those theorems. But that's what's going on. So what you're going to be doing then in the section 2 homeworks is going to be taking a story problem situation, drawing a picture, making a right triangle out of the picture, and using SOHCAHTOA to solve for the missing piece. So here it says Christy is looking up at the Fisher Building in downtown Detroit. Okay, well, she's standing 200 feet from the base of the building. Notice that I assume that the building is standing 90 degrees to the ground. That's an assumption you can make for all structures that are coming off of the ground unless it's stated otherwise. And she finds the angle of elevation. So this would be our angle of elevation, right? And she says that's 66 degrees. And we're wanting how tall is the building. So I'll call that H for height or something. Is everybody okay with how I've constructed my picture? Okay. To solve for H, what trig function should I be using? So relative to the angle that I know, that angle of elevation at 66 degrees, the two sides I either know about or want to know about are H and 200, correct? Is the 200 opposite, adjacent, or hypotenuse? Relative to that angle, that 66 degree angle, opposite, adjacent, or hypotenuse? Adjacent, I heard somebody whisper. What about the H? Opposite, that's correct. So the trig function I should be using is SOHCAHTOA. Tangent, I heard somebody whisper. Start saying it louder, guys, so you can have some bragging rights and stuff. So tangent of 66 is equal to opposite over adjacent. Looks good. To solve for H, then, we'll multiply both sides by 200. And now it's calculator time. Before I go typing this into my calculator, though, what do I need to check? The mode of my calculator. In this problem, what is the angle measured in, degrees or radians? Degrees. What mode does my calculator need to be in to do this problem? Degrees. Mr. Kulik, on this test, am I going to have to be careful about switching back and forth from degree mode to radian mode on my calculator? You betcha! The good news is in the problem, it always is going to tell you, like, either directly or indirectly, that needs to be in degrees or radians. So I have 449.2 feet. How does that feel? No big deal, right? The hardest part is getting the picture. Once you have the picture, it's just like these review problems from geometry that we did at the start of the year, which I think we all felt pretty decent about, if I recall. I know it was a little while ago. Insert. Let's do another. All right. Jane has climbed a tree. Oh, that silly Jane. And looking down at her friend Mary. Jane has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? So it says the angle of depression is 49. Where's that 49 degrees going to go? So Brody, you're saying right here. This is the most common mistake students are going to make that is incorrect. Remember, Jane is looking forward here. This is like her line of sight. The 49 would go there. So what is that angle supposed to be there at J? So it should be 41, or you could use alternate interior angles and label angle M as 49. Or, alternatively, instead you could draw this triangle in blue and use the 49 where it's at. Any of these are acceptable routes on finishing this problem. What you don't want to do is put that 49 in the wrong spot, though. Everybody's okay? I promise you, you're going to see a problem just like this on your test. I'm going to try to trick you to get you to put that angle of depression in the wrong spot. I'm telling you now to look out for this. Does everybody understand where the 49 needs to go? You're going to remember to be careful about it in the future. I'm telling you right now that I'm going to try to trick you again with it. Okay. So let's say we're using the blue triangle, and we wanted to know how far is Mary standing from the tree. So let's say that's X. That's going to be the same X as that up there, right? Because what I've basically just drawn is a rectangle. So relative to the 49-degree angle in the blue triangle, I'm going to be using the blue triangle. The X side is opposite, adjacent, or hypotenuse. So I'm using this angle here. X is opposite, adjacent, or hypotenuse. Adjacent. And the 17 is opposite. So the trig function I want is tangent. So tangent of 49 is opposite over adjacent. So to solve this for x, I need to get that x out of the denominator. So I'll multiply both sides by x. And then to get the x by itself, I need to divide both sides by tan 49. And now it's just calculator time. So I know that I just changed my mode back to degree mode. So I don't have to worry about that. So I have about 14.8 feet. What do you guys think? So far, so good? Pretty easy, right? The hardest part is getting the picture right, making sure you get your angles in the right spot. We'll do one more example and we'll be done with section 4.2. But this is a doozy of an example here, guys. So hang on to your proverbial butts. Says here, Claude and Simone are riding bicycles in Paris. How romantic for them. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? Yes.
Is that?
Sure. Is everybody okay with the picture I've drawn here? So 32 degrees, we go 100 meters closer, now it's 37.5 degrees, and we're just looking for this H. So far, so good? So if I look at this picture that I've drawn, I see two right triangles. I see this big one, and then I also see this little one. So I'll put in the little right angles. Everybody see that? Now in either of those two right triangles, do I know a side and an angle? I do not in either of them, right? In the green triangle, all I have is an angle, and everything else is unknown. In the blue triangle, all I have is an angle, and everything else is an unknown. But what do I notice is part of both triangles? Is like this side here that I'm going to call X. So if I split this into two separate pictures now, so far so good with how I've drawn my two pictures. If I look at the base of the second triangle, that's the green one, what label should I give the base of that triangle? Should be X, right? Can everybody see that? What about the blue triangle? What should I give as the label for that base? Not 100, and not X. How far is it to go from here to here? X plus 100. You go 100 feet, and you go X more. So we'll call that side X plus 100. Do we feel so far so good? In each of the two triangles, the sides that we have labeled are adjacent and opposite. But both of them still have two variables in it, right? They both have an X and an H. What I'm going to do is I'm going to create a system of two equations. So using the blue triangle, I'm going to say tan 32 is equal to opposite over adjacent. And in the green triangle, I'm going to say tan 37.5 is equal to opposite over adjacent. Is everybody okay with what I've done? What I'm going to do now is I'm going to solve this system using either substitution or elimination. What I'm going to choose to do is use substitution, because all I really care about is the H. I'm going to take equation 2, get the X by itself, and then substitute that in for equation 1. Is everybody okay with that plan? So I'll multiply both sides by X. and then divide both sides by tan 37. And I'm going to take this value for x and plug it into the first equation. In doing so, I have eliminated the x variable what I'm left with is something looks pretty yucky, right? I have h's in two different places. Everybody see this? So to kind of unwrap this, what I first want to do is I want to take care of this fraction inside of a fraction business that I have going on. You guys see how I have the little fraction h over tan 37 inside of the bigger fraction? I hate that. That looks confusing as all get out. So what I'm going to do to fix that is I'm just going to multiply the top and bottom by tan 37. So when I multiply h by tan 37, I just get h tan 37. When I multiply tan 37 to h over tan 37, what do I get? For this multiplication here, what do I get when I do h over tan 37 times tan 37? I just get h, right? And then I have to do 100 times tan 37. So I've taken care of the fraction inside of the fraction piece. Everybody okay with what I did there to do that? Now, the next step is I have to get the h's on one side and everything without an h onto the other, right? So I'm going to get rid of the fraction part of this by multiplying both sides of my equation by h plus 100 times tan 37. Everybody okay with what I've done there? I'm going to then distribute that tan 32. And now I'm going to subtract the h tan 32 to the other side. So I have the h's on one side and the stuff without the h's on the other. Now my mission is accomplished. I have the h's on one side, but I don't have the h in just one place, right? I need to get that h from two separate h's to one single h before I can continue. How do I get those two separate h's into one spot? Well, if I look at these as two separate terms, do you notice anything in common between them? Is there a common factor between the blue and the green? They both contain a factor of h, right? They both have an h in them. What I'm going to do is I'm going to factor that h off. Does everybody see what I did there with the h? And then my final step will be to divide both sides by tan 37.5 minus tan 32. And that'll get the h by itself, right? I know that's was some intense algebra. So into my calculator. Here I'm definitely using that horizontal fraction bar because, boy, that's going to be a nightmare to get in my calculator right without it. If I do that, I get 336.6. And notice that when solving my system, did I find x? No. Do I care? No. Now, who liked the algebra that we just had to deal with here? None of us, right? So you remember, go back to solving a system of equations because that's really what we had to walk through. Other than substitution and elimination, do you remember any other methods for solving a system? Do you remember graphing as an option? It was. Now, the catch here would be to use graphing, we'd have to have either the h for both of them or the x for both of them isolated. So let's say that we isolated, well, the h certainly looks easier to isolate, right? So let's say this, if I multiply the first one by x plus 100, oops, that's not what I want to press. That one. So I'm going to assume y is like my h. So if I multiply the first equation by x plus 100, and the second equation, if I multiply just both sides by x, that would give me x times tan 32. I'm sorry, 37.5. I'm then going to graph these two equations and look for the intersection. So if I hit graph on my calculator, so I see the one equation, but Mr. Kulik, I don't see the other one. I don't see an intersection. Did I do something wrong? No, man, the window's only going, what is the window? Just going from -10 to +10, right? X is going to be like this distance to the Eiffel Tower. H is going to be the height. I don't know how far these things are, but I know they sure as heck can't be negative. And I bet they can be pretty stinking far away, right? The Eiffel Tower seems pretty tall to me. I know they're at least 100 meters away from it. I don't know how much further they're going to be away from it, but I'm going to go like 0 to 500 or something. Just going to take a guess. If I do that and I draw my graph, there I'm getting two curves. And, I just barely get them crossing, but barely is good enough. You see them crossing right there? To find that intersection, then I just do second and trace and pick the intersect command. Now, your calculator is going to ask you three questions. It's going to ask you, what two curves do you want to find the intersection of? And then whereabouts should I start looking for this intersection? Here's the thing. On a problem like this, we'll only put two things in. And since they're straight lines, they're only going to cross in one place. So my answers to this question for my calculator don't really matter. So I'm just going to press enter 3 times. Because I only graph two curves, and they only cross in one place. So the only thing it can find is the answer. So it tells me there the intersection is at x is 438.6 and y is 336.6. Remember that I used y as my h, and I used x as x. So the y coordinate is representing the height for the tower. I would argue that that was probably a bit easier of a problem to deal with than walking through all the algebra solving that system. Once, again, as far as I'm concerned, once you have this system written, if you sketch a picture and say that you just use your calculator to find the intersection and write down your answer, that is okay. If you want to go the algebra route and you're like, yeah, I'm good at algebra, I'm going to do that, that's fine too. No big deal. Either way, your problem should show like a picture, the system, and then whatever method you use to solve that system, whether it's graphing or algebraic, is okay with me. How do you guys feel? Okay. All right, question for you guys. One more thing. Your homework is going to be worksheet 3. I didn't print this one off for you, but it's in the OneNote already. It's just some like 7-story problems or something, or 6-story problems. I don't remember how many story problems it is, but they're just like the ones in the examples that we did. By my watch, it looks like, what do we got, like 15 minutes left in here? What's your preference? You want to squeeze the homework quiz in today or do it on Friday? Okay. Friday it is. Josh? They'd be part of Sundays. Yep. Just as a reminder, on Friday, that's going to be our review day. That's the last day of Chapter 4. So you'll be making your half sheet when you start on that, when you finish with your homework quiz. Probably just walk in and hand it to you. If you have individual questions about stuff like any of these story problem things, we can cover that stuff after the homework quiz. But since that stuff won't be on it, I won't worry about answering any questions beforehand. That feel okay to everybody? You good with the plan? Again, if you want to start your half sheet early, you're welcome to do that. It'll be due at the end of the class on Friday. But if you're like, I want to take my time and like talk to my tutor or whatever, this is me giving you advance notice. But this chapter, there's like much less like memorization formula stuff than the previous chapter, right? This is basically just like a handful of skills. The only real formula stuff that I would like think is super memorizey would be like this criteria for knowing whether you're adding or subtracting. I might include an example problem and just have that criteria written in there or something like we did on this first one, but this chapter to me feels kind of easy in that regard, where it's not a lot of different skills going on and not a lot of formulas and stuff that we're using, right? Everybody feel okay? Okay. Take your last 15 minutes or so. You can work on some homeworks. If you have homeworks to catch up on, you can start on worksheet 3 if you want to start on that. But I'm going to stop the recording now and just